Hey everybody, this is Larry. This is me trying to do an extra question on January 18 of the year 2023. I'm going to do a medium one, obviously that I haven't done before. Hope it's not an SQL problem. Is it? No, okay. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's extra question. And again, we have, this is not a premium question. Is there a way to make it premium only? Well, I'll look into it tomorrow or something. But it just feels weird because I don't know. I feel like I complain about it every day. But anyway, today's problem is 1162, as far from land as possible. Let's take a look. So you have an n by n grid where only values are 0 and 1. Okay. 0 is water, 1 is land. Okay. Find a water cell such that the distance to the nearest land cell is maximized and return the distance. Okay. Yeah, so n is equal to 100. That means that there are 10,000 cells, and it's probably very tempting to kind of for each water find the nearest land, right? That's probably like your first thought, and that's probably my first thought for a brief moment. The only thing that kind of prevents you from doing it is kind of it's what was I going to say? Oh yeah, the only thing that prevents me from doing it is that yeah, it's no bueno, right? Because it's going to be too slow. 10,000 square. If you visit every, in the worst case, it is going to be too slow and it times out, and no one's happy. The core idea for this one is kind of a graph-ish problem, a grid graph problem, which is something that's very popular on these things. So I don't know how much real life applications these have, but there are a lot of properties that you just kind of accumulate over time from practice because you've seen enough, or a lot of them anyway. I don't know if you ever seen enough grid problems. And for this particular one, the key is noting that maybe we can think about things backwards, and that's something that is easy to say, but sometimes hard to do. Even I kind of mess it up from time to time. But yeah, think about backwards, right? Meaning that for each cell, for each land, you kind of, the way that I would think about it is kind of expanded from the land, right? So let's say we have, let's just say we have, just some whatever, and this is not a square. I probably made it too big. Whatever. Let's just do it this way. The idea here is that okay, you have land, right? Then here, by definition, you can almost think about it. I think some people used to call this frontier, and you could think about it just like a breadth first search of basically expanding one space ahead, right? And so maybe the way to think about it in English, like verbally, or to articulate it, is like, okay, well, what cells are one space away from this land, right? Okay. Well, the cells that are one space from this land is just you take every cell and you convert this so that this is one distance away, this is one distance away, this is one, and so forth, right? So you take all the cells that are one distance away and mark it as one. I probably messed that up. And then next, what are the cells that are two distance away from the closest land, right? Now, for all the ones, you can make it into a two, right? Because all the water that is next to a land piece that's one piece away, it's going to be two cells next, and then three, and then so forth. So that's one way to think about it. And of course, if you kind of do it iteratively, looking at every cell, that's going to be too slow. But it turns out that you, with enough graph practice, this is just breadth first search from. I think the precise term is multi-source shortest path algorithm, and that's basically the idea, and that's basically the reduction, and that's also like one of those things where you look at the code and you're like, oh, this looks not bad, but then you have to really kind of dig into the logic and really understand it. The other thing is that this is Manhattan distance, so yeah, that means that up, down, left, right each costs one step, and that's like another way of saying it. Okay, so yeah, so we just breadth first search. So for x in range of n, for y in range of n, let's also say we have a deck, right? We have a NQ algorithm of x, y, and d for distance, right? maybe we have something like, how do we want to do it? Like best is equal to none times n for basically n by n grid, right? And then basically and you go to this and also q dot append xy, something like that, right? And then now if grid of xy is equal to 1, then we basically want to enqueue the land because every land is 0 distance from a land, right? That's fair. Yeah, so then best of xy is, oh sorry, what am I doing? I was just reading the problem while typing it, and I was typing up nonsense. As we said, all the land is going to be 0, so let's do that. And then now, while find a water cell such that, okay, yeah. So I kind of forgot what they're trying to, or what the exact problem. I was just looking at the problem because I want to see what the exact problem was looking for. But yeah, so it goes to q dot pop left, right? DQ, if you will. Maybe you could do a function for it, but it's fine. And I think one thing that I forgot to do is directions, and in this case we want up, down, left, right. Not necessarily in that order that I'm typing, but yeah, the 4 directions, right? And then now we just check for each one in directions. Oh, I usually do dx dy, and then now, of course, for breadth first search, we just have to check to make sure that is in bounds. And that we haven't seen it yet. If we haven't, then I don't. Well, I could write it this way, but I guess technically what we want to do is enqueue nx and y with this number, just to kind of keep it that way. And then yeah, that's pretty much it. And then now at the end, for x in range of n, we want with no land or water. How do I return -1 there? Basically, we want to find a water. Okay, so yeah, basically if this is none, then we return -1. I think this actually returns on the first thing. Well, I mean, it's either that or there or yeah. So basically, best is equal to some really big number, right? Right. So if this is none, what does this mean, right? That means that there's no land, so we never enqueued anything here, so nothing got popped, and yeah, so it's all water. You could probably also just check for it, to be honest, just like with an if statement, because this is way maybe annoying to kind of understand the logic for. But yeah, otherwise, ends is equal to min ends of best xy. Yeah. Oh, only if best of xy is equal to, oh, not best, if the grid is water, right? Which one is water? 0? Yeah. And then if answer is still this infinity number, then we return -1 because it's all water or all land. Yeah, it's all land. So then otherwise we don't answer. Oh, no. Expected to. Did I misunderstood this one? Oh, maximize. I am clearly a dummy in reading. But at least this one is easy to fix. Maybe not. Oh, well, then in this case, this is wrong. That's why. Because we're maximizing, obviously, it's not going to get bigger. All right, let's give it a submit. Hopefully, I should have tested the all water and land case actually as a test principle. But yeah, I mean, this is pretty standard breadth first search, which means that has very standard breadth first search complexity, which is linear time, linear space, and by that I mean v plus e, and of course v is n squared, and e is also n squared times 4, or roughly speaking, both of which is O of n squared, which is the size of the input, which is, as I said, linear time, linear space. Cool. Yeah, that's all I have for this one. Pretty quick for this one, but let me know what you think. I would say this is a relatively standard E problem for interviews, especially maybe nowadays when things are kind of going a little bit tough. So yeah, let me know what you think. Let me know how you did it. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.